Good morning to one and all. This session we are going to see the manufacturing of the composites. There are several techniques which involved for the manufacturing of the composites: hand layup techniques, pressure bag and vacuum technique, next protrusion technique, Russian transfer molding technique. Next one is finally injection mold techniques. These are techniques available for the day-to-day life, the manufacturing of the composites. While manufacturing of the composites, these techniques have to be followed. This is the easy way for manufacturing techniques. There are several testings should be carried out after the manufacturing of the composites. This techniques helps us to inculcate the composite material in the very good manner for the user-friendly day-to-day applications. First one is an introduction. The composite material consists of two distinct materials which together improve the product performance and lower production costs. Composite material typically includes platted, clatted, coated materials. However, the term composite materials involved mean the material consists of matrix or basin substance. A reinforcement of materials. The matrix acts as a blender for the reinforcement while controlling the physical shape and dimensions of the part. The composite materials, the only means consists of the two materials. There may be a matrix form and reinforcement form. The two types, the matrix and reinforcements, they plays a vital role for the composite material manufacturing. The matrix acts as a blender for the reinforcement while controlling physical shape and dimensions of the part. Its primary purpose, however, it is used to transfer load thrust applied to part of the reinforcement. The matrix protects the reinforcement from the adverse environmental effects. The reinforcement function is to be enhance the physical properties of the composites. It's typically main loading bearing element. The reinforcement are usually in form of either fibers and particles. The reinforcement is main functions to enhance the mechanical properties of the composite materials. Typically main loading and bearing element. The reinforcement are usually in form of fibers and particles. The reinforcement and matrix or materials can be in polymers, metals, ceramics and carbons. The most widely composite materials are the fiber reinforcement thermostatic polymers. The composite material can be defined as a combination of two or more materials that retain microstructure resulting in a material that can be designed to have improved properties that conceits of the loan. The introduction. The advanced composite material have been used to fabricate many structures parts in engineering application. This is due to their most attractive characteristics such as lightweight, high strength, stiffness, good fatigue resistance, good corrosion resistance. They enable to manufacture the parts within complicated geometry using fewer components, enable manufacture to save as compared with the parts made for conventional materials. The different stages for existing of the materials concerned up to the final product. At this stage, the material appear in the raw basic form. This consists of either fiber in form of filaments or fiber bundles. The fibers can be woven into the fabrics into the for a matrix. The materials are usually appears in the liquid form of a thermoset resin in granular in form of a case of an thermostatics. At this stage, fibers and matrix can be combined to the single layer. For the in case of thermostatic matrix composites, the matrix can be appeared in the semi-liquid, semi-solid form so that the sheet can be holded shape. For this case, the thermoplastic composites, the matrix is solidified. This form for the thermoset matrix composites are called as a pre-Q. For the thermoplastic composites, it's called as a torque. These are the techniques and stages for the different stage of composite material.